Good afternoon, everyone. This is the April 24th, 2024 meeting of the Science and Data Subcommittee of the Vermont Climate Council. My name is Jared Duval, co-chair of the subcommittee with Colin Smythe. And so I'm going to just first want to welcome folks for joining. We have some special guests today from the Environmental Protection Agency, the National Center for Environmental Economics, for what will be the main part of our agenda, which is a presentation about the recent report on the social cost of greenhouse gases that was published by the Environmental Protection Agency in November of 2023. In addition to that, before we get started, we're going to consider and seek to approve our minutes from our previous meeting on April 5th. After the presentation, we will have time for Q&A and some discussion. We'll start with subcommittee members, and then we'll also leave time for public comments after the subcommittee members have had a chance to ask questions and engage in discussion. And then we'll wrap up with some discussion of our next meeting date and agenda before we adjourn. So with that overview, I will turn it over to Colin for the first agenda item.
Great, thanks, Jared. Give me one second. I guess the first thing, let's kick off with approval of the minutes from the last meeting. Apologize, Jared actually just recently pointed out to me that the date was actually wrong on those. I corrected that, and I hope it uploaded correctly in the new version that I just pasted in the chat. I can check on that right now, but yes, looks like it is correct in there. So aside from that change, does anybody have any issues with the meeting minutes from the last meeting? All right, seeing none, I think we will consider those approved. And then, yes, I guess I will, Jared, pass it back to you for kind of introduction of Elizabeth and kicking us off here. That sounds
Thanks,
good.
Colin.
Thanks.
And Breck, did you come on screen just to start your video, or was there something you wanted to mention? Okay, great. Thank you. It's good to see you. And anyone else who is able to, we would welcome you to turn your videos on so we can see your faces, but no pressure. So we are incredibly fortunate today to have with us Dr. Elizabeth Kopitz, who is a senior economist at the National Center for Environmental Economics of the United States Environmental Protection Agency, where she has been for the last 20 years. And she has some colleagues joining her. Dr. Kopitz she led the development of the report on the social cost of greenhouse gases that was published by the Environmental Protection Agency in November of 2023. And so once that was published, we reached out because just to set some context, folks may remember that as part of the scientific underpinning of the climate action plan that the Vermont Climate Council wrote in 2021, we established a social cost of carbon or social cost of greenhouse gases for use in estimating economic impacts related to the climate action plan and its mitigation scenarios that were modeled, and also for use in benefit cost analysis. And at the time, we made a commitment. We knew that there was an interagency working group process across the federal government underway to incorporate the latest advances and best research across the scientific community in updating those social costs of greenhouse gases, but it hadn't yet, that report, which we will hear a presentation about today, had not yet been published. So we had committed that those were kind of what was in the first climate action plan would be interim values. And then we wanted to keep track of and hear updates about the latest advances in estimating the social cost of greenhouse gases and reflecting that in future work of the Science and Data Subcommittee and of the Vermont Climate Council as a whole. So hopefully that is helpful context. With that, I'm going to invite Elizabeth. Hopefully you can go ahead and share your screen. Perfect. And I think the way that we were thinking of doing this is primarily let's give Elizabeth the chance to go through her presentation, and then we'll hold questions from subcommittee members until the end, or there may be some kind of sections of the presentation where Elizabeth will pause if there are any clarifying questions as we go. But let's follow Elizabeth's lead on when to take questions. Don't want to preempt questions that you will otherwise get to in your planned presentation. So thanks again for joining us, and over to you, Elizabeth.
Okay, thank you. And thanks so much for reaching out and for inviting me to talk, and mostly for your interest in EPA's updated estimates of the social cost of greenhouse gases. So I also have my boss, Al McGartland, who's the director of the National Center for Environmental Economics, joining today, and at least a few members of our team of economists who authored the report and help with the analysis. So maybe more will trickle in as we go along. So as Jared said, I'm going to give you an overview of EPA's recent update that was issued as part of an oil and gas rulemaking last December. And I'll try to get through the whole thing, and obviously we're happy to answer more detailed questions on any aspect of the analysis. So I know you all have some understanding of this, since you already use estimates of SCC in analyses in Vermont. So hopefully I won't give too much background, but in case there are folks on the call who are relatively new to this topic, I did want to do a little bit of 101 to start off before we get into the methodological updates. So first and foremost, what is the social cost of carbon? So it's defined as the monetized present value of global net damages from emitting a ton of CO2 into the atmosphere in a particular year, or conversely, the benefits from a ton decrease of CO2. And so that automatically tells you that this is a year-specific value. And in principle, it is a comprehensive metric that's trying to reflect the value of all future climate change impacts, negative and positive. And so that is, of course, a very challenging undertaking, and one that we will never fully be able to measure in all aspects, right? So in principle, you're trying to measure all the ways that human welfare is affected by climate change, induced changes to our food, water, the air we breathe, the weather we experience, all our interactions with the natural and built environment. But of course, in principle, in practice, all of our estimates are going to be partial measures, given that we will always have data and modeling limitations that are going to restrain the ability of analysts to include all the physical, ecological, and societal impacts across our global complex landscape. But still, the estimates we have, they're trying to provide a measure of the incremental or marginal benefit of abatement, right? So it's how the effect of changing emissions by a small amount. And that is what we need when we do benefit cost analysis, because that is how we're going to value the benefits of reducing CO2 or another gas, right? And comparing that to the incremental cost of a policy. And as we know, this is not the same thing as the carbon price from a policy that specifies an environmental target, like capping emissions or temperature, because that carbon price is a measure of the marginal cost of abatement, which can be very useful in cost effectiveness analysis, but it's not an alternative way to value damages from CO2 emissions in a benefit cost analysis. And I like to always remind people that, you know, that carbon price derived from an environmental target, it does implicitly require evaluation of damages when you're setting that constraint, even though you're not explicitly modeling or estimating that. And these two measures are only going to be equal when that target is set at the economically efficient level. So now throughout this presentation, I may say SEC or social cost of greenhouse gases interchangeably, because there are, of course, estimates of the social cost of other greenhouse gases like methane and N2O. We also have developed some estimates of social cost of HFCs. And so these gas-specific measures value the changes in each of their emissions. And collectively, we just refer to this as the social cost of greenhouse gases. So most published estimates of the SEC have been developed using what are called integrated assessment models, or IAMs. And these are models that try to integrate climate processes with the global economy in a single modeling framework. And there's lots of different types of IAMs out there. The kind of IAMs that are used to estimate social costs of carbon are often referred to as reduced form IAMs. And they are the type that carry the analysis through to provide an estimation of monetized damages, which is not mostly feasible from other, perhaps more structurally detailed integrated assessment models that are used for different types of analyses. And the current models out there that do this generally take an enumerative or sequential approach to estimating 4 components or steps to this process, okay, which are shown in this diagram here, which you may have seen various iterations of this. So the first, because emissions of CO2 today is going to remain, of course, in the atmosphere for centuries. To calculate the effects of that, first we have to project what the world is going to look like in terms of population, GDP, emissions, multiple centuries into the future. And then you want to calculate the impact of those emissions on the climate, on mean global temperature or regional temperature, sea level, various endpoints. In the second step, which often we talk about this as the climate modeling step, but it's more than just temperature often. And then in the third step, you're trying to translate the impact of these temperature and other climate changes into damages, and monetizing those damages and aggregating them up into the future. And then to arrive at the damages today from this future stream, we have to discount the future stream of damages to the year of the emissions change. And so this 4-step procedure is basically done twice, both with baseline emissions and with a small additional pulse of emissions in a particular year. And the SECO2 is that per ton difference in present value of the future stream of damages due to the pulse of emissions. Now, there is increasing attempts to try to capture some feedbacks and interactions between the components, for example, feedbacks from damages back to socioeconomic conditions, but it's still pretty limited today due to computational challenges and data limitations. So this is one area where folks are trying to make improvements in getting those feedbacks and interactions. So why do federal agencies at least need social costs of greenhouse gas emissions? Well, for us, we use these estimates primarily in regulatory benefit cost analysis, but we have also encouraged its use in non-regulatory contexts for some time now. So benefit cost analysis is part of the US federal rulemaking process, and it has been for multiple decades now by executive order. And it provides a consistent framework for comparing regulatory designs that have different costs and emission reductions for different pollutants, for example. We have lots of other types of analyses that are required by statute or other executive orders or discretionary, and they provide insight into different dimensions of a rule's impacts, like distributional analysis, EJ analysis. But SCC is what we need in BCA to develop an aggregate measure of affected individuals' willingness to pay for reducing climate change impacts associated with policy actions that affect emissions. That said, we find them also useful in assessing impacts of actions, even when we're not doing a full benefit cost analysis. So for example, EPA has been encouraging the use of social cost of greenhouse gas estimates in environmental impact statements that are done under the National Environmental Policy Act, or NEPA, which are done for proposed infrastructure and other projects that require federal permitting, and and in other aspects as well. The idea here is not to get some precise estimate. It's more that you leaving the value completely unaccounted for in your analysis is not what we want to do, right? And this was echoed in the seminal 2008 Circuit Court ruling that remanded a fuel economy rule to DOT for failing to monetize the CO2 emission impacts, stating that while there's a range of values out there, it's certainly not zero. And so despite the uncertainty, we included in our analyses. So as I mentioned, we've mostly been using this to date in federal benefit cost analysis, and in the non-regulatory context at the federal level, it's popped up in many NEPA analyses. There's been some use in project level BCAs, and most recently, the Department of Transportation's update to their guidance for applicants to DOT's discretionary grant programs includes recommendations for applicants to use our EPA's recently updated estimates for a wide range of surface transportation infrastructure projects. Some legislative proposals have been informed by some of these estimates. In the IRA, for example, the social cost of methane estimates did inform the waste emission charge schedule set for oil and gas sources in that act. And in last September, the White House issued a directive further encouraging federal use of estimates beyond regulatory analysis. And we've also seen increasing use of SCC by non-federal entities, for example, states like you all and many other states. I included a link here to a organization that tries to track state use of SCC. It might be useful to you if you haven't run across that yet. Most recently, I just saw that California is starting to use the EPA's updated numbers in some of their analyses of their cap and trade regulation. And Canada has also adopted our update last year when it came out as a proposed update. I won't go through all of this background, but you can look at it later when I distribute the slides. But the point here is just we have been at this for a very long time now. Folks in our office are, we really have done the technical modeling work to support the development of the interagency working group estimates on social costs of greenhouse gases when it first began in the beginning of the Obama administration, when that IWG was formed to bring some consistency and rigor to the various values that were being used across agencies following the court ruling. And then in 2017 is when the National Academies of Sciences issued their a final report making recommendations to the IWG for how to go about updating the estimates over time to ensure that they reflect the new science as it becomes available. And then during the last administration, there wasn't much government-led effort to address those National Academies recommendations. Instead, there was an executive order at the beginning of the Trump administration that disbanded that group and instructed agencies to make 2 adjustments to the IWG estimates to focus really on the quote domestic share of damages and higher discount rates. And then in the beginning of the Obama administration, beginning of the Biden administration, that group was reestablished and called for a renewed focus on updating the values, and set some interim values initially that really put the estimates used by agencies back at the late Obama era values. And so EPA during this time, of course, continued to review developments in literature and further improve our estimation of the social cost of greenhouse gases. And we released a draft update of these estimates addressing the near-term National Academy's recommendations in a proposed rulemaking in late 2022. And then we took public comment on that through that rulemaking, and also initiated a separate external expert peer review of our methodology, which we completed in May of last year, so about a year ago. And so when we issued the final update in the final oil and gas rule in November of 2023, that included our response to public comment and external peer review recommendations. So now we are starting to use these estimates in all our primary analyses of regulations affecting GHG emissions. This slide just summarizes how the methodology underlying these various iterations that I kind of just walked through has changed over time. I know it's really small. You can look at it in more detail later, and we're going to focus on the EPA 2023 numbers, but hopefully you can sort of see from this summary is just how little the underlying methodology has changed until now. So all the IWG recommended estimates and even the numbers that were used in the Trump administration, were based on 3 integrated assessment models, DICE, PAGE, and FUND, which were the most widely used for estimating these numbers back in 2010. But some of the inputs to these models that we made common across the 3 really haven't been updated at all since 2010. And even the damage functions, we've had 1 update in 2013. So really those interim IWG numbers that have been in use since 2021 in this administration still rely on modeling developed over a decade ago and are based on underlying scientific assessments that are significantly older in some cases. So a little preview of our results. We find that these updated estimates are responsive to the near-term National Academy's recommendations, offer an improved scientific basis and greater transparency of how they're implemented in their results. And here I've just put in a couple quotes from the peer reviewers who really had a very favorable review of the updated methodology. And they explicitly say it represents a huge advance and provides the basis for an improved estimate now and the foundation for continuing improvements in the future. And you can find, I'll give you at the end links to everything. So if you're interested in looking at all the peer reviewer comments and our responses to them, you're welcome to take a look through those as well. The results are based on improved characterization of major uncertainties in all aspects of the modeling, and they are larger than what we've been using in our analyses up until now. So for example, the updated central social cost of carbon is about $190 per ton of CO2 for 2020 emissions, which is more than 3 times the IWG estimate of $51. But most importantly, there's still many categories of climate impacts that are not captured in the updated estimates. And we have a large section in our report that discusses this and goes through that in great detail. So just to give you I'll kind of walk through some of the National Academy's recommendations as I go through each module and how we updated it. But their main recommendations was to unbundle the steps of the SCC estimation process into what they're calling modules. So back in that picture I showed at the beginning where the 4 steps, they're calling those, they say separate it out into 4 modules. Don't just rely on one IAM from the literature as is, but try to update each module based on expertise, the latest expertise within the relevant disciplines for that module, and to try to address, quantify uncertainty at each stage of the process and propagate that throughout. And then they also gave us long-term recommendations for each module and some recommendations regarding process in how often they think an update would make sense to balance that need for incorporating new research as well as a more thorough estimate and maintain a thorough, predictable process. So here are some near-term recommendations, but I'll walk through these as I talk about each module. So this is another way of looking at the 4 steps that I showed you before. So we can start with the socioeconomic module, because we adopted their recommendation to take this modularized approach. And as we walk through, you'll see when we were evaluating alternatives for how to update each of these, our goal was to adopt updates that improve consistency with the current state of scientific knowledge, enhance transparency, and allow for more explicit representation of uncertainty. So for the socioeconomics module, the National Academies recommended to use a mix of statistical methods and expert elicitation to project contributions of GDP, population growth, and emissions into the future. And so that is what we did. We reviewed the available sources of long-run projections for these variables that would be necessary for damage calculations. And we found that the most recent projections coming out of the Resources for the Future Carbon Initiative, the Social Cost of Carbon Initiative, which was a collaborative effort led by RFF and Berkeley and researchers from many other institutions, really stood out as being the most consistent with the National Academy's recommendations. So first of all, they provide a set of probabilistic projections, which was really emphasized by the National Academies. They take into account the likelihood of future emission mitigation policies, technological developments. They also go out far enough in time to account for the vast majority of discounted damages without us needing to make additional extrapolation assumptions the way we did with the IWG back in 2010. There we were using a selected range of deterministic projections for key variables coming out of a Stanford energy modeling form exercise that went to 2100. And then we had to make some simplifying extrapolation assumptions out to 2300 for the modeling. Here, these projections go out much further in time to 2300, incorporating uncertainty throughout that range. And thirdly, they allow for capturing economic growth uncertainty within the discounting module, which we'll talk about a little bit later, but this was also a key point from the National Academies. So let's see, and they use this mix of statistical and structured expert elicitation judgment methods that are explained in great detail in our report, and happy to answer specific questions about any of that. But in the interest of time, since I always take too long to describe this, I'm going to move on to the climate module. And this is a module that takes emission projections and models their impact on CO2 concentration and the resulting temperature dynamics. And as I mentioned earlier, the methods used to date really relied on averaging the results of the DICE Fund and Page IAMs, each of which has its own representation of the climate system but none of which are really up to date with the current scientific advancements in the field. So for this update, what we did was follow the NAS recommendation, and here they were very specific in pointing us in the near term to using this reduced complexity climate module called FAIR, which is an open source and widely used climate model highlighted by the National Academies and used by the IPCC. The uncertain parameters in it are calibrated to be consistent with the IPCC AR6 for key parameters like climate sensitivity, etc. So these kinds of reduced complexity models have a long history of use in climate science assessments. They're really useful for this type of modeling exercise because you can run them quickly. You're able to explore uncertainty, and they can be used to model the temperature dynamics from a pulse of emissions in a given year. So their projections of future warming are consistent with the more complex state-of-the-art Earth system models, but you can actually use them for the type of exercise we have here. So these figures just show the projected future atmospheric concentrations of CO2, mean global surface temperature through 2300 based on the RFFSP's emission projections that we use as inputs to the FAIR modeling. So the ranges of uncertainty you see here reflects uncertainty both in emissions and the physical climate processes that are consistent with the projections coming out of AR6. And because when we're trying to calculate the social costs of greenhouse gases, we're looking at the impact of a marginal pulse of emissions. You also want to see how the climate model responds to small changes in emissions. And that's what the last panel of the picture shows you, is the temperature response resulting from a pulse of CO2 in 2300. And it's important to kind of emphasize that the temperature dynamics in FAIR really is a big scientific advancement over what we had in the climate components of the earlier 3 IAMs we've been using. So this picture is from Dietz et al., who showed that the initial response of Dice, Fund, and Page to a pulse of CO2 emissions was slower than the response of FAIR. And this is this red line, and the green bands show the response of FAIR calibrated to like over 200 models used in the 5th phase of the CMIT-5 project. It's a model intercomparison project, and that shows that FAIR can better emulate the high resolution global climate models. And this is important because for when you're calculating the SCC, the near-term marginal damages are going to be discounted less than the damages far into the future. So getting this temporal path of the temperature response, it matters. So that brings us to I should also mention, in addition to temperature change, 2 of the damage modules that we use in our report require global mean sea level rise projections. And so we do have 2 different methods for doing that within those 2 damage modules. I don't have time to get into that right now, but it's described in detail in our report, and we're happy to answer questions. So this brings us to the damage module. And this is the core part of the IAM that maps temperature change and other physical impacts like sea level rise into monetized market and non-market damages. Okay, so market damages would include lost labor productivity, lost agricultural productivity. When we talk about non-market damages, we're talking about trying to monetize the human health impacts, ecosystem service impacts, things like that. And it's arguably the most challenging part of the SCC estimation project process to update. And that's because you have functional forms and calibrations are constrained by the available literature out there. You're trying to extrapolate beyond warming levels or locations that have been studied. you have comparability issues and methods, and it's challenging to synthesize the current understanding of damages out there. It's also an area where the older models were critiqued, and increasingly critiqued over the years because they really rely on science that lags behind the latest research. So this figure kind of shows you the publication year of the studies underlying fund, page, and dice, as well as the blue bars show newer research that's come along since then. So it's great that we have this large increase in research on climate impacts and damages since the time of the original, the 2013 update. But of course, we still have a wide variation in methodologies. And so in some ways, it's almost harder to kind of get your head around that now than it was then. So what EPA did was we did a thorough review of all the various approaches to damage function estimation, and we followed the National Academy's near-term recommendations for how to go about this. And we really tried to focus in on the approaches that try to improve the understanding and transparency about the mechanisms through which climate impacts are occurring and how each sector contributes to the overall results. And so to do that, we focused on damage functions that are estimated by spatially explicit or sector-specific modeling of processes to build up, your damage module. And so the first two, so we ended up using 3 different damage functions, and the first 2 of these really take this more bottom-up impact-specific approach. The first one is the DSIM model, which was developed by the Climate Impact Lab, or CIL, which is a multidisciplinary consortium of climate scientists, economists, computational experts, researchers, et cetera, from many universities, including University of Chicago, Berkeley, et cetera. Its strength is that it uses very spatially disaggregated data and econometric methods to derive empirically based damage functions, empirically based damage relationships. And this addresses a common criticism related to damage functions by folks such as Bob Pindyke, that they're empirically grounded, and these impacts, the response functions are estimated from over 25,000 different impact regions, and they're able to capture nonlinearities in terms of how climate and income affects the response to temperature. And the authors also developed a way to account for adaptation and its costs in making these projections. So it currently includes 5 sectors or impact categories. The second is the GIVE model, which I think you all are somewhat familiar with, because I know it's in Evelyn's nice review last summer, I think, of Vermont's use of SCC. She included some discussion of the GIVE model that was developed by RFF and the Berkeley group, and its damage functions are directly responsive to the National Academy's recommendations to update sectoral damage functions based on recently published work reflective of the current state of knowledge in those sectors. And the NAS specifically pointed to mortality, energy, agriculture, and coastal damages as areas where there was that were ripe for updating. One of its strengths is that it was developed on this MIMI platform, which is an open source package for constructing modular IAMs, which means that it can accommodate additional damage sectors as research evolves. And it can also accommodate different temporal and spatial resolution within its different components. Finally, given the newness of both DSIM and GIVE, EPA decided to include a third damage function. as a way to reflect the synthesis of the state of knowledge in other published climate damages literature that had been published up until that point. So we do this through the most recently published meta-analysis that directly estimates an aggregate global damage function. And we found the most recent one to be published by Howard and Sterner in 2017. So the sample of studies that underlie that third damage function, there were 20 studies published through 2015. So there's no overlap between the three. All right. That brings us to the discounting module, which is an important update here. So in this report, EPA shifts away from the use of a constant discount rates to a discounting module that discounts the future climate damages back to the year of emissions using a dynamic discount rate approach based on the Ramsey discounting formula. And this allows us to account for the relationship between economic growth and discounting. So for those who are not familiar with the Ramsey formula, it describes optimal consumption discount rate, that's RT here, as a function that explicitly reflects preferences for utility in one period relative to utility in a later period, also called the pure rate of time preference, or rho in this equation you see on the screen. And second, the value of additional consumption as income changes, which is the second part of the equation. And it's a product of eta, which is the elasticity of the marginal utility with respect to consumption, and G. And G is that consumption growth rate, which is varying now over time, right? Because remember, the RFFSPs included probabilistic projections of future consumption growth rates. So if we have uncertainty in GT, then there's uncertainty over the discount rate over time. So EPA incorporated this uncertainty using the Monte Carlo method of taking draws from probability distributions of G and making the Ramsey discount rate this dynamic parameter within the modeling. And then each Monte Carlo scenario is discounted using the calibrated rho and eta values and the specific consumption growth rate for that scenario. Now, the rho and eta parameters for the Ramsey formula were calibrated so that the decline in the certainty equivalent discount rate matches the latest empirical evidence on interest rate uncertainty, as estimated by Bauer and Rudebesch, which is the latest paper, as well as the average of the certainty equivalent discount rate over the first decade matches a near-term consumption rate of interest. And so we handle the uncertainty in this starting rate by using three near-term targets rates, 1.5, 2, and 2.5, based on multiple lines of evidence of observed real interest rates. And there's a whole discussion, as you can imagine in the report, on the details behind this. But all of this is to say that we use these three dynamic discount rate paths, and this is consistent with the National Academy's recommendation to use three sets of Ramsey parameters that reflect a range of near-term certainty equivalent discount rates and are consistent with theory and empirical evidence on consumption rate uncertainty. This discounting approach is also consistent with the latest OMB guidance. The Office of Management and Budget puts out guidance for conducting regulatory analysis, and they just put out an update in November. And that update recommended consumption-based discount rates of 2%, and which is our central near-term discount rate here. And they explicitly endorsed Ramsey discounting for longer-term discounting. So this graph this figure just shows the distribution of discounted marginal damages coming out of the modeling using each of the three damage functions and the three near-term discount rates. This is showing you for 2030 emissions. Okay, and so you'll see that the uncertainty grows over the modeled time horizon. So you can see in the box and whiskers plots here, in cases with a lower near-term target discount rate, which gives relatively more weight to impacts in the future, the distribution of discounted marginal damages is wider. And across the 3 damage modules, DSIM-based runs generate the widest distribution of results. So there's discussion of this in the report, but the DSIM damage module has like a greater degree of curvature in the damage function, that mapping temperature to damages than the other 2 specifications do. So that's part of it. To generate a set of numbers that reflects the uncertainty in the whole process, but also provides us a manageable number of estimates for policy analysis, we ended up averaging the results across the 3 damage module specifications to account for the multiple lines of evidence on the damages module. And we find this is a reasonable approach when your alternative damage functions account for overlapping impacts, but are based on independent lines of evidence, both of which we think is true for our current case. And this table shows the rolled up results after averaging those estimates across the damage functions for each gas and each near-term Ramsey discount rate. And so you see how we have estimates for all years, but this just shows you how the values increase over time. Now it's important to remember that the increase in the change in estimates from how these change from the IWG estimates is really due to the combined effect of all the methodological updates. And so some of these are integrated in a way that makes the complete decomposition of each update or the incremental contribution of each change kind of difficult to do. So we can answer more questions about that, but just to move on here, as I mentioned earlier, we have a really long section of the report that talks about all the ways that many impacts and associated damages are not yet captured. And this table and the following one is just taken from the report to show you what types of climate science processes, as well as impacts and associated damages, are or are not yet captured in the estimates. And you can kind of just scroll through by seeing all the open little circles that there's still a lot missing, right? So neither DSIM nor GIV yet accommodate estimation of other categories of driven climate impacts, like morbidity impacts, conflict, migration, biodiversity loss, damages that result from physical impacts other than mean temperature and sea level rise change, things like ocean acidification, extreme weather events, things like that. And importantly, as I mentioned earlier, there's a lot of feedbacks and interactions that are not yet reflected in the estimates. In some cases, some of these omissions are due to research on physical endpoints not being in the form that is suitable for monetization, right? So we have many methods out there for monetizing certain morbidity impacts, but we don't yet have good projections of the morbidity impacts resulting from a pulse of CO2 emissions change. In other cases, it's the flip. We have some, like the FAIR model calculates, generates projections of measures of ocean acidification, but we don't yet have global functions that translate the pH and ocean heat outputs from FAIR into monetized global damages. So these are all areas that we're working in. Finally, I just have kind of a summary slide here talking about how do we actually apply the values to stream of estimated emissions changes. Since you all already use estimates, maybe this is very familiar to you, but remember the estimates represent damages associated with a ton released from the perspective of the year of emissions. So when you're conducting policy analysis about policies that affect GHG releases into the future, we have to apply the gas-specific SCGHG value corresponding to the year of the estimated emissions change according to this formula, and then you can incorporate the results into the rest of the analysis by calculating the present value of the resulting stream of monetized damages. So you're discounting back to the year of analysis. And recently our office has created a spreadsheet to help analysts with these calculations. I don't know if there's interest, but I think my colleague Charles Griffiths has joined us, and he's happy to kind of just show you really quickly how it works. Charles, are you on?
I am.
Okay.
All
Do
right.
you want to share your screen quickly and maybe do that? I can
Yeah.
stop sharing.
Yeah. How long do we think you want this to go? I can accommodate whatever we think is right.
I think I don't know. Jared, is this
Yeah.
is this helpful to you all? Or you like
I mean,
a shorter
sounds,
version?
it sounds like an incredibly helpful resource that would be good to kind of click through and get a brief overview of. I would defer to you, Charles, in terms of, I would say the shortest in which you can do it justice. If 5 minutes is possible, that would be great.
We can do it in 5 minutes. All right. Not a problem at all. All right. So,
Thanks.
But please don't feel rushed. I mostly just want to, it's hard to know on the other side how many questions we will have. So just wanting, the only reason I say on the shorter side is just to make sure we have as much time as possible for questions, but please take the time that you need to do a brief overview.
Nope, I know how to do this. This is not a problem at all. All right. So the first thing is that we have the report on social cost of greenhouse gases that Elizabeth described. It can be found at epa.gov/environmental-economics/SCGHG, or if like me, you just simply Google EPA SC-GHG and you should be able to get a link to it. Down at the bottom, we have the report Elizabeth that we wrote that Elizabeth was describing. And the third link down is the workbook for applying SCGHG estimates. We version it, so this is version 1.0.1. If you click that, you should be able to download this spreadsheet. And it has a number of tabs. The README tab describes all the other tabs, and it also has a link to the report. But if you have the spreadsheet, you probably have the link as well. And then we have a technical background sheet, which describes a lot of the things Elizabeth described, including the overview of the SCGHG estimates by decade. And then there's a number of other sections here on discounting details that we skimmed over. The most important is that the EPA used a Ramsey discounting approach, which is appropriate when you're discounting for, say, 300 years, as we were. But if you're doing an analysis over a short period of time, say 30 years or less, you probably can use a constant discount rate. The spreadsheet currently discounts things back at a constant discount rate. The instructions tab describes step by step how you go through the spreadsheet if you have emissions reductions from any regulation which you're doing. And that walks you through what you're supposed to do. But the most important things are that you enter your data on the data tab in the lavender, orange, and green boxes. And then the results are on the results tab in the light blue cells. And so the spreadsheet begins unpopulated, but we have a helpful example in the example tab, which illustrates how the recent oil and gas rule by the EPA could be calculated using this spreadsheet. And you're able to copy that data and paste it over into the other tab. Most of the tabs in this workbook are protected, which means you can't enter anything except where we want you to enter data, but you can copy it. And so you can copy this data if you forget how to use it and paste it in. The important things to notice are that the data runs from 2024 to 2038. The present value year is 2021 for the oil and gas rule, and the dollar year is 2019. That is the purchasing power year for which they recorded the data. So we can take that data, we can paste it into the 2024 cells here. So we'll paste it as numbers and make sure that the dollar year is set correctly in 2019 and the present value year is set correctly at 2021. They are for this illustration here, but if you have a different years, you would populate them. Now, what the spreadsheet will do then is once you enter the data and the present value year and the dollar year, the spreadsheet does everything else for you. It will produce a present value of the monetized value of the emission changes, and it also create what's called an annualized value. I don't have a lot of time to talk about annualized value. Are you having trouble seeing it, Jared?
Nope.
Okay, great.
Just leaning in.
Okay, good, awesome. So if you have any questions later about annualized value, we can talk about it. However, that annualized value is listed, the number of years in that annualized value is listed here. We have a handy dandy little check marks to show what your study period is. The important thing is please make sure that the check marks are all a continuous stream. That is, you've entered values for everything where there are emission changes. You don't enter zeros outside the emission changes years, and you don't enter any zeros or any information for the other gases, only where you have emission changes. The values that Elizabeth talked about for the SCGHG are down here, and this is where the spreadsheet draws its data for the calculations, and this is what Elizabeth talks about. In addition, because we have that dollar value year, we may have to adjust for inflation. Down here is the GDP deflator we use for that adjustment. You don't need to know any of that. You should just know that it's there. So the equation that Elizabeth had on her last sheet was that the way you calculate the value in any given year, so the 2030 value for the methane reductions, if you were to go down to the area, you'd have 2030. You would say that the social cost associated with reducing methane emissions in 2030 is 2,403. If we multiply that times the emission changes in 2030, then we get a value in 2030 discounted at the 2% rate using the Ramsey equation is 10, these are in millions of dollars, so this would be $10.6 billion. Now that's the value in 2030 that society would be willing to pay. We then discount it back using the constant discount rate to the present value. The discounted values are presented here. If we sum all these, we get the present value of those emission reductions. So for the oil and gas rule, if you actually were to go to that rule, you would find that the discount rates of 2.5, 2, and 1.5 have present values of 83 billion, 108 billion, and 150 billion dollars for that particular rule. Here are the annualized values again, which I won't discuss today. If you had other emission changes, those values would be presented here in the CO2 and here in the N2O sections. And then they're all summed for the total value of your emission changes. So that's basically how the spreadsheet works. Again, there's an example in which you walk through, and we discuss some of the things up here in these steps about how the example works to help you understand it. There's a facts page, which includes some frequently asked questions and issues. We will populate that as we issue new versions of the spreadsheet, and then the release notes, which tell you about the releases. So that's the spreadsheet. I'd be happy to take any questions on this, or Elizabeth would probably, you can ask Elizabeth questions at this point if that's part of your agenda.
Great. Thank you both so much for those overviews. And at this point, I think, unless there's anything else that you wanted to add, Elizabeth, I think we can open it up to questions from members of the subcommittee based on either your main presentation, Dr. Kopitz, or the walkthrough that you just gave us, Dr. Griffiths. So either way, anyone from the committee with questions? Ken.
Yeah, I just want to note for the folks there that one of the categories that's not included in terms of the costs is flooding. And so as we use values such as this, and I know there's mention that this is going to be kind of a low estimate, recognizing that not all of the costs have been incorporated. But for us in Vermont, the fact that it's not including flooding damages, I think, is an important message that there still is a lot more there of costs that have yet to be included in this work. And if I'm right, if I missed that, please let me know, because that was a message I would send out to folks.
No, I think that is correct. So our damage modules do not include inland flooding related damages currently that I know is on your minds a lot lately. And so that is an area where we're hoping to make progress in the coming years, and definitely is on our mind the need for better representation of flood related damages.
Thanks.
It was really striking, Elizabeth, seeing the table that you presented about just how many damages are not estimated in the damage modules, and it raises for me that, well, one, it is a reminder of how inherently conservative the resulting figures likely are, but second, it leads to an interesting question about, as you look to these every 5-year updates, do you have a sense already of what additional damage modules you are expecting or hoping to be able to incorporate into future updates, or is that still not known?
Well, there's always new research coming out, and we're always looking to see what things are capable of being folded into the global models. One recent thing that we've been looking into is trying to incorporate Earth system feedbacks associated with tipping points. And there's a paper that we talk about at length in our report that has made some progress on that. So here we're trying to incorporate, say, the carbon feedbacks from certain Earth system changes like Amazon dieback, permafrost thaw, things like that. And so these are things that you'd be incorporating within the climate module part of it that would then propagate throughout the rest. So it's not adding a new damage category, but would have an impact on everything. And that's an area where we are in the process of making updates and being able to fold some representation of those into the GIVE model to start. That's based on published work, but I expect there to be more coming out on that front in the coming years. So that's like one example, but there's a whole slew of in-house and outside research that's ongoing that hopefully will be ready to be folded in a few years.
Great. Breck, I saw you had a question.
Yeah, Elizabeth, a really impressive piece of work. I have 3 what I hope are very simple questions. The first one was I noted in going through the report that you were using in the FAIR model, the 1.6.2 version, and I just happened to look up the FAIR model, and there was a newer version of it, a version 2. Is it substantially different, or are the results pretty much the same?
I do not expect the results to be that different. There was a reason we didn't use 2, and I'm trying to remember what it was, but maybe someone on our team can answer that more quickly for me. Brian, do you?
Sure.
Do you recall?
Yeah,
Was it not calibrated to AR6 yet? What was the reason?
Yeah, they actually, so the reason, so FAIR 2.0 is rapidly under development. Well, first, good catch, Breck, but throughout the stages of the development of our report, FAIR 2.0 was still under development.
Ah,
In the IPCC, it actually used what version 1.6.2. So to maintain consistency with the IPCC's
Sure.
approach in AR6, we stuck with 1.62 for now. That being said, there aren't large differences in the global response of global mean surface temperature between FAIR 2.0 and 1.6.2. So
thanks.
Yeah.
And one other clarification, just for me, on your slide 18, which was about the distribution of the social cost for greenhouse gas values, is that distribution the value of the Monte Carlo analysis of the uncertainties? Is that what that is representing?
Brian, do you want to
go
take
ahead.
that?
I was, yeah.
No, go ahead.
I don't have the report in front of me, but I think I know which figure you're talking about. Yes, exactly. So those are, we're careful to say that's not a distribution of social costs. However, it's a distribution of net present damages. Social cost actually captures the concept of risk and uncertainty and capitalization, and that is only fully captured when that distribution is actually collapsed into a mean value. Theoretically anyway. And so while we present that distribution, it's not necessarily a distribution that you can pick and choose from and say, this is the SCC from this Monte Carlo trial.
Yeah. And so the values that were in Elizabeth's slide number 19, which was the table, what were those mean values? Is that right?
That's correct.
Yes, those are the mean values. Yes.
Okay. And if I could, one last question. So and I'm not an economist, right? But I think I understand the math behind the Ramsey equation. But I have a question about if I admit a metric ton of carbon this year, it's going to have impacts going on for 300 years. I'm going to emit another metric ton next year, and it's going to have impacts over 300 years. Are those impacts in the model additive? And if they're not additive, where is it accounted for? Where is the non-additivity accounted for? Because it's not being accounted for in the Ramsey equation. That's purely economically driven. Is that being accounted for in the climate module? Or maybe in the socioeconomic model? I'm not familiar with the models behind those. So in other words,
Charles,
I got a metric ton of CO2 that's emitted this year, and it has an impact on forests or flooding or whatever. Is another metric ton added next year an additive effect, and so that it has double the impact? And if it's not, how is that non-additivity accounted for?
I think, let me take a stab, Charles, and then maybe I'll miss the mark. But I think, Breck, what you're getting at is the range along which these greenhouse gases are being emitted, and so it's additive along, like, so the social cost of greenhouse gases is a marginal measure, and so this is additive linearly. It's double the impact, essentially, I think is what you're saying, because we're on the margin in the overall magnitude of global emissions when it comes to carbon dioxide. If you were to emit 10 gigatons this year, 10 gigatons next year, you might not see that linear relationship. But when we're talking magnitude so small as metric tons, that it is additive in that sense. Maybe that's what you're getting at, but maybe Charles has a better answer.
No, I think he's got it right. It is a marginal effect. And so if you have a marginal effect this year and a marginal effect next year, they're the same. However, the damage function is nonlinear. And so as the, sort of in the baseline, we have more and more GHG emissions in the atmosphere. And so we have an increase in the damage function. So the marginal impact in 2030 is going to be different than the marginal impact in 2040 because of that movement along the damage curve.
So that's being accounted for in the damage module. Got it. Okay, thank you.
Yes.
Great. Thanks, Breck. Leslie Ann, please go ahead.
Thanks, everybody, and thanks for the entire team for being here and sharing all of this great information. I have some bigger picture questions, primarily because of some of the National Academies committees that I sit on. And I was curious about the interface with the National Climate Assessment process and the ways in which the development of the report, which is similar to the timing that the NCA 5 came out, how much crosswalk and crosstalk was going on at that particular time. And I have 3 other questions, so maybe I'll pause and let you go through one by one.
Yeah, there isn't much overlap. You know, the National Climate Assessment is a multi-year US only assessment, whereas here we're looking at what can global IAMs tell us. And so I think there is some discussion of SCC in general in NCA 5, and there are a few of our colleagues in the climate change office are more involved with the National Climate Assessment than our office is, although we sometimes review drafts and things like that. I think that's right. I don't know if Al or he's still on, or if others have any other thoughts on that interaction that are worth mentioning.
No, I think that's right. I thought you nailed it, Elizabeth. They're pretty independent activities, I think.
Because it would seem to be a nice opportunity to do a little bit more interfacing, just like the climate change indicators that EPA puts out specifically for the NCA process. This would be another great set of inputs to raise that level of awareness in there.
Yeah, I think one thing to emphasize that Elizabeth talked about was these global IAMs, up till now at least, have needed global damage functions. So it's really hard to find that in the literature, as opposed to just damage functions for, say, the US, which is more data rich than other countries. So DCIM in particular goes out of its way, I think, to use statistical methods to make sure that they're properly accounting for, you know, in-country conditions, etc. Whereas, but I think the NCA is definitely, you know, sort of more US centric, which so that's another. But I like the way you're thinking. I think that would be a good crossover. So we'll take that back as well.
Can you speak to some of the unshaded circles in the slide I talked about, the scope on climate science, impacts and damages, specifically like the ecosystem services one? None of those were shaded in. Similarly, for the extreme weather, which included things like droughts, wildfires, and floods, was also not shaded in. And I'm just curious what the direction is in helping to, you know, address some of those, because I'm thinking about it from what is of importance here in the state of Vermont, including adaptation, nature-based solutions, and some of the elements in that realm, and the ways in which we can expand the use of the things in the report and the process to help speak to some of those concerns.
Sure. Well, I can start, but others should chime in. So there is a lot of work, I think, ongoing related to wildfire damages and trying to develop better estimates of wildfire-related damages, not only in the US, but again, the challenge is I think primarily related to the projection of these types of events globally in this type of modeling framework is a challenge. But that is an area where I see some movement, especially if you just focus in on US related modeling efforts. On ecosystem service related damages, there is work underway that I think will be available soon, that at least tries to develop global damage functions for biodiversity loss. And so I see some movement there, but that's just really one aspect of ecosystem impacts. There's so many others. Al or Brian, Charles, David, do you have any examples you think we should highlight?
Not that's being worked, but I think the point's well taken. As you know, as climate related extreme weather events get more intense and more frequent, then nature-based solutions become even more valuable, right? Because wetlands will prevent, more intense damage from hurricanes, etc. So my own gut is thinking that we may have to move away from demanding global damage functions and think about regional damage functions and try to build something up. Some coverage, Elizabeth mentioned, some coverage is better than none. And so at the outset, so I think we have to be less demanding, I think, of what goes into our models and think about how we could do stuff, say, for North America or Africa or South America, depending on where the data lie and where the damages take us.
Thank you for that. So I'll just end with a comment. And it's really nice to see how the Academy's consensus reports are being used, because we're always on the lookout for what is the next big consensus report that we should be working on. And so it's nice to see the sort of the other side of the coin in terms of how responsive a lot of the work that comes out of going into a consensus report actually plays out. So thank you for that.
No, it's been so important to us, and it's really kind of our guiding light. Sorry, Al.
Can I give a shout out to that? Because the Academy report came out in 2017, I think. Elizabeth, correct me if I'm wrong, but that really did, because of both the short-term, near-term recommendations they made and the structure they gave to the report and the specificity of which they gave us advice. Obviously, with the previous administration, we didn't do a lot of work in climate change, but it did allow these outside research groups that Elizabeth mentioned, the Decent Climate Impacts Lab group, and then the folks at Berkeley and RFF, et cetera. They had a kind of blueprint which allowed a tremendous amount of coordination of research across these different research groups, and foundations actually helped support it as well. So it did become, work was progressing, even though EPA, our office in particular, wasn't really focused on it at the time. And then we picked up the baton when the Biden administration came in.
Thank you for that.
Any other questions for the EPA team? One thing I'll just note is as we look to consider a recommendation for updating the established social cost of carbon dioxide and other greenhouse gases in the next climate action plan. And we'll note, so for committee members who are interested, pages 52 to 55 of the initial climate action plan is where we address the social cost of carbon. And what we borrowed from at the time was the estimates developed by the New York Department of Environmental Conservation, working with Resources for the Future, and we'd recommended that a range of discount rates be presented, but that we utilize the central rate. And it's one question I wanted to ask you, Elizabeth, or anyone else from your team, is that in that set of values that we utilized from New York, the range of discount rates that they presented were 1%, 2%, and 3%. And I'm seeing in your report that it was 1.5%, 2%, and 2.5%. Is that, can you speak to, I don't know what, in the previous work that EPA had done, what the range of discount rates presented was, if that was also a change, but can you speak to the reasons behind that and why you thought that was the appropriate set of ranges to present it to us? I think it will raise a question of, do we want to revise not only the values that we point to, but also the range of presented rates?
I'm going to I just want to say one thing, but I'm going to let Charles take this because he's a discounting expert. Not, but it's really important to keep in mind that we shifted the whole way we're doing discounting here. So it's really not appropriate to compare a 1% constant to a 1.5% near-term target rate. That's a dynamic discount rate going forward. And we do have extensive discussion in the report on how we got to the selection of those three that maybe Charles can sort of summarize now more eloquently than I could.
Yep.
Charles.
I can't summarize more eloquently, but I can add a little bit. So previously we were using a constant discount rate. So it wasn't the Ramsey equation, it was a constant discount rate. And for the previous report, we used 2.53 and 5, oh gosh, was it 5? Okay, yeah. And that was based on a fact that we're trying to work off the consumption rate of discounts. So we don't want the opportunity cost of capital. We don't want to assume that we're displacing capital. We want to assume that the impacts here are in consumption. So this effort, because we're using the Ramsey discounting, we were trying to get the rate which reflected that lower consumption rate of discounts. So discount rates have declined over time. So currently they range in the 2% range currently. And so that's the starting rate for the Ramsey equation. And then based upon the period over which you calculated, what data set you use, you can get ranges of 1.5 and 2.5. And so that's how we chose our range. The problem is in using the Ramsey discounting, it's difficult to go down much lower than that. Because if you figure out that rho and eta Elizabeth described, once you parameterize the model, we're already using a rho which is effectively 0. So we have a 0 rate of time discount on the present to the future, and all we're really talking about is growth rates. So if you take the growth rate, you'd have to sort of find a way to move your eta in ways that probably aren't consistent with what the theory is currently telling us. So until we find a more complicated way or a more advanced way of dealing with how we deal with uncertainty, that's the range that makes sense in the Ramsey framework. And so that's why so they're actually so excellent. So we have the range here of the rho and eta that we're actually using. And you see at the 1.5, eta is close to 1. Once we start getting below 1, we have there's some questions about intergenerate or equity concerns on how we treat transfers of wealth between rich and poor in ways that probably don't make sense given the concern about the poor currently that we have in this administration.
Thank you, Charles. Anyone else from the subcommittee or supporting state staff have any questions or comments that you'd like to share? Okay. With that, I think we want to open it up if there are members of the public joining who would like to ask a question or make a comment. You'd be welcome to do so, and now is a good time. Okay. Well, thank you so much for taking the time to join us and walk us through this and the just immense amount of work that you did to improve the scientific underpinnings, not just of United States federal policymaking and rulemaking, but I hopefully, as is clear today, the benefit that it also has to individual states who are working on their own climate action plans. So it's incredibly appreciated, your work and you joining us.
Well, thank you so much for inviting us and for your interest. And I will send along the slides, and it will include a slide with links to our webpage and things you might be interested in. And of course, we are happy to talk anytime with any follow-up questions you have.
Thanks so much. And
thank you.
You are welcome to stay on, but we will probably just be discussing our next meeting date. So you're also welcome to leave, and we will. Yeah. So.
Okay. Yeah, we discussed enough meetings in EPA. Take care.
All right. Okay. Bye-bye.
Bye.
So, but before we totally leave this subject and discuss the next meeting, and this relates to the discussion of the next meeting, I think a question for the subcommittee is kind of what do we do with this information and our next steps. We had a meeting of the steering committee of the Climate Council on Monday. And at that meeting, it was approved for us to have at our next meeting some support from the facilitation team at CBI, so that having taken this information in, we could go through a subcommittee process to consider a recommendation to the full council around updating, now that there are updated values, updating our recommendation for the appropriate values and research to use regarding the social cost of greenhouse gases. So I think that's one thing that we want to discuss and consider is our kind of timeline and process for doing that. But just glad to be able to share that we will be able to have some facilitation support as we walk through developing a recommendation that could then go to the full council for consideration as we kind of prepare for updating the climate action plan. Hopefully that additional context is helpful. Colin, I think over to you.
Yeah, thanks, Jared. Yeah, so I guess just to talk a little bit about potential next dates. The recurring meetings that I set up have officially ended as of today. And so I guess would like to get a sense from you all if kind of the dates and times of these meetings have been working, which would be Fridays and Wednesdays as we've been doing. Yeah, it's been a long time since we polled everybody, but it was very kind of difficult to find a spot that worked for everybody, and I think those two tended to be the best. If anybody has kind of different schedule or other thoughts on time, or if they would like me to try to poll everybody again and find a different time, potentially on the same day, as opposed to the Wednesday, Friday schedule, please speak up.
When we have a number of new members who it would be nice and inclusive if we could ask all of our new members as well, everybody at the same time, if the days and times work. Because that was what we did last time, but it may not work for our new folks.
Yeah, thanks, Leslie, and that's a good point. So maybe, sorry, Brett, go ahead.
Well, just in response to Leslie Ann, the Wednesday works for me. I'd prefer to have it be a constant day, just so muscle memory is, okay, I need to go to this meeting on this day.
Fair enough. It was previously Friday, and then we had one member who absolutely could not ever do Fridays, and so we switched it to the Wednesday, Friday. But from Leslie Ann's suggestion, which I think is a good one, maybe I will reach out and kind of poll everybody again and see if there is a better date time, and that will kind of enable the input from all of our new members, even those who aren't on the call today. So thanks for that suggestion, Leslie Ann. Claire, you want to go ahead?
Yeah, thanks, Colin. I was just going to mention that I know one of the ways that the Just Transition Subcommittee thinking about operating or planning to operate in this iteration of the CAP is to designate liaisons to all the subcommittees. And I think Sophie, that subcommittee just met last week, and I think Sophie Beltrop in the Climate Action Office has a list of folks who were interested in which, and it just might be nice to include the folks who were interested from Just Transition scheduling poll. I think that the liaison role is intended to pick up over the summer and through kind of the bulk of the CAP work. So
I think that is a great idea. Thank you. I'll reach out to her to get those and include those folks the poll, and we will see what we can find. I guess I'll just put out there that we were envisioning sometime, and Jared, correct me if I'm wrong, but around May 24th. And obviously we'll send out the poll to get the exact date, but sometime that was before the next Climate Council meeting, which I'm not sure of the date of. It's in June sometime, so I'd have to check that. But so that assuming we do go forward with a recommendation to update the social cost of greenhouse gases, that it could be potentially taken up at that next Climate Council meeting.
And that's currently scheduled for June 17th.
Okay, thanks, June.
And there is a steering committee meeting of the council on Monday, May 20th, in which we're planning to discuss whether we're going to we want to keep that council meeting date or whether we might adjust it because of some various scheduling issues. But I do think that regardless of whether it's a Wednesday or a Friday or another day, it would be good if we could aim to do our next meeting that week of May 20th, just so that we could get clarity on whether or not what we would want to be able to share with the council at the next meeting or the subsequent meeting.
Great. Ken, go ahead.
Yeah, during our last meeting, we reviewed a document that was kind of our, I don't know what it was called, procedures or guidance from and it had a lot of emphasis on the progress report. Is there a progress report schedule so that we could use that to help us kind of scope things out?
I don't know if there's an official schedule, but I know that Sophie has been working very diligently on trying to track down various agency staff members to fill out the missing information in there. I believe she was hoping to have, I don't know about if wrapped up is exactly the word, but kind of as best as she could get it, I think by this Friday. So as soon as I get that, I will send it out to all of you. But yeah, she has been doing a lot of work on that for sure.
Great, thanks.
Sure. All right, I guess the other part of what we were hoping to talk just, or maybe a rundown of the next agenda, so would be a potential for me to kind of I'm just starting to put together the next iteration of the greenhouse gas emissions inventory and forecast report. And so I'm kind of going through the different sectors and contemplating kind of some updates to some of the methodologies and data sets. Nothing too major at this point, but I'm kind of working through that. And so the thought that Jared and I had was to have me kind of at least give a rundown to this group of a couple of those methodology and data set changes that I'm considering for the next inventory, and just kind of get reactions and thoughts from this group. And so just interested to hear if people like that idea or would like to hold off until kind of the process is a little farther along. And honestly, it kind of depends on when this meeting is scheduled and kind of how far I've gotten at that point. But yeah, I just wanted to get some general feedback on that idea. Claire, go ahead.
I think that sounds useful and timely if there aren't any other major pressing items. I think for me, and this might just be me, but it would be helpful to have kind of a sense of what the work plan for the subcommittee is going to be over the next year. I know that's what other subcommittees are starting to talk about, and it kind of feels like absent this conversation about updating the social cost of carbon, and then changes to the GHG inventory, like a little uncertain how we'll be operating over the rest of the year. So that is just something I would find helpful, but maybe that's just me.
Yeah, that's a great point, Claire. And it reminds me that at the last meeting we had talked about, and I can't remember who from the state team, if it was Jane or Sophie or you, Colin, we had talked about kind of a schedule and timeline of the different pieces of contracted analysis, given that that's a major role of this subcommittee in terms of the review of drafts, and a place for those discussions and presentations to happen. Having a sense of and I know that there's uncertainty there, right? Like how long the RFP process takes, the selection process, delays in the actual research, but having a sense of the ones that are underway and that are related to this subcommittee and a kind of anticipated timeline, a range of possible times when we would have drafts for review, I think would be really helpful to not as the sole work plan, but to inform the work plan that Claire's talking about.
Yes, I do recall that from the last meeting. I would just say I don't think there's been a whole lot of movement on that front since the last meeting at this point, but we can certainly put that on the agenda and try to get especially Jane in here and maybe Brian Woods to kind of give an update on what they're working on that front. And yes, I can certainly at that point probably provide a little more information on the measuring and assessing progress tool, contract progress as well. But yeah, like you say, there's definitely some uncertainty in where the different things will be at specific times at this point. But we can certainly provide whatever updates we can.
Yeah, because there's a lot of really important work there on pathways, leap modeling, lots of other pieces. Great.
Leanne, go ahead.
So just to piggyback and add to that, this might be another place where we can do some cross cuts. Both Jared and Colin know that the Rural Resilience and Adaptation Subcommittee have asked for an update in the climate and climatology and that space, and it might be a good idea to sort of bring the same piece into this subcommittee too, because we are thinking of updating at least the writing and knowledge that we've had in the last, 3 years now? Isn't that amazing? Yeah, 3 years since we've wrote that piece. So just putting that as part of the work plan. So apart from all of the contracted stuff, the expertise of the subcommittee itself, and how do you bring that to bear with contributing to all of the pieces that could and should go into the updated plan.
Yeah. Leslie, if it's okay, I have a clarifying question on that. Do you think that it would make sense to share with this subcommittee the invitation to attend the presentation that you're already going to do at Rural Resilience, so we have that opportunity? Or are you suggesting an additional opportunity, just wanting to not make too much work for you, especially if it would largely be the same presentation, or if you're envisioning different presentations? But we could certainly do the former.
It could be either or, because I think what happened last time is things were so rushed, plus a lot of the information was coming out, the NCA was embargoed, so you couldn't share it as freely as you could have shared it now. And so to the extent that all of the cutting edge science stuff that we're talking about is now more publicly available and public knowledge, that we can actually bring that to bear so that other committees, subcommittees that are working on stuff and writing up stuff don't have to wait until the very end or 2 weeks before the very end to try and include that as part of what they're looking at.
Yeah. That's great. So we will plan to include that via email, but just for folks who are interested right now, just seeing that email from Marion about that Rural Resilience and Adaptation Subcommittee meeting, for folks who are interested, that will be, looks like May 10th from starting at 11 o'clock. If folks want to mark their calendar now, and if it's not already, I imagine that will be up on the in our Climate Council page with the link. Okay. We will wait to see when the scheduling comes out. I think I would just ask people in the meantime, in case it comes out similarly, if you can try to hold times on Wednesday afternoon or Friday morning, the 22nd or 24th of May, just in case it ends up coming out the way that it has in the past. But we'll try to confirm that relatively soon. The other thing is that in addition to some of the updates on the methodologies and data sets that Colin's considering related to the inventory, I think it probably would make sense to follow up on this presentation from the team at the Environmental Protection Agency with a draft recommendation for consideration from this subcommittee to the council regarding updating the social cost of greenhouse gases for use in our updated climate action plan. And I am happy to volunteer to help draft something for consideration. If there's anyone who would like to work with me on that, would be happy to work with others, but so just want to pause on that.
I'm happy to work with you on it, Jared, if you want.
Great. And if there's anybody else, otherwise we can work to get something drafted for consideration. Breck, was that a hand or a wave?
Yeah, I'll give it a shot.
Awesome, thank you. Okay. Great.
All right. I guess we could ask for any additional public comment, but I don't think there are any members of the public left on the meeting. But maybe I'll pause for just a second anyway. All right, well, any other discussion or business from any of the subcommittee members?
I have just a really simple question. Our meeting notes, will they be appearing on the resources page of the Climate Council?
I have been putting them on there. I honestly have to go back into the recording to do the notes generally these days, but we've kind of fallen off having a committee member take them. So I'm going to work on putting that together. I will also post the recording. I will upload them to the resources page, or let me take that back. The resources page, I'm assuming I have kind of a SharePoint link that I think links to the resources page. I haven't actually checked it, but I do link whatever is in there to the calendar invite for this meeting. So I will, if you click on this meeting in the Climate Council calendar, it will be in the documents at the bottom of that will be the meeting recording and the meeting minutes.
Okay, thanks.
Sure.
Just one timing thing that I wanted to note before we end is, and please correct me if I'm wrong, Colin, my recollection is that at a previous council meeting, I believe the one in January, there was a presentation that Jane Lazorchak gave where she was talking about an aim of having kind of a regular publication date for each annual greenhouse gas inventory. And my recollection was that that was June of each year. And if that is planned to be the case, then I just want to note that I do think it would be really important and valuable to make sure at this next meeting at the end of May, we do have that would be a really timely opportunity to hear any possible updates regarding suggested methodology or data set changes. Just so that the subcommittee is aware of and would have a chance to ask questions about that and discuss that before a decision had to be made so that the inventory could be kind of finalized and published.
Yeah, we have not completely finalized that date yet, but the hope is to get it out in June. So I'm doing my best to go as fast as I can to kind of get all that put together. So my hope is June, and yeah, would be happy to talk about that the end of May, but I'm not going to promise at this point. But
okay. Great.
All right.
Anything else? before we?
Jared, I wondered if you had a copy of today's presentation, or could request one if you don't.
Yes, Elizabeth said that she would be sending that to us right afterwards, and we will get that posted. Colin, correct? You're the one who actually knows how to do it and does it, but I imagine that we can just upload that to the resources portion of this agenda item in the calendar, or this meeting.
Yeah, I'll put that in the documents, the kind of same place. So if you click on this meeting on the calendar, it will be down at the bottom, kind of in the documents area. And this is something I should know, but I'm not sure anymore if there's like a resources kind of a tab on the website. Is that what you were referring to, Ken? Or anyway, there may be a resource, or I'm sorry, Breck was the one who asked that question. I'm not sure if there's a resources tab or whether or not that is continually updated. So it may be that tab would link into this kind of repository where I put this. But regardless, it will be in that location that I mentioned in the calendar.
Yeah, on the front end, there's a drop-down menu that you can select just resources from the Science and Data Subcommittee. I don't know what's happening on the back end, though, with respect to wherever you put it, whether and how it shows up in the resources library.
Gotcha. Thanks. Yeah, I should investigate that because that's a detail I should know, but don't at this point. So I'll check that.
It would be convenient rather than having to go back through the calendar to different meetings to be able to go to the resources page and find anything that we needed relative to the Science and Data Subcommittee.
Okay, yeah, I'll see if I can get that sorted out if it's not already set up that way or have been maintained that way.
Great, thanks, Colin.
Sure. All right. Anything else from anybody? All right, hearing none, I guess that will conclude our meeting for the day.
Thanks everyone.
Thanks,
Have a good day.
everyone.